Is the process of removing water, excess salts, sodium plus and potassium plus, glucose and urea from the blood. This begins in the glomerulus, where blood flows through and eventually goes into the Bowman's capsule to be stored. This mixture of substances is called glomerular filtration. About 180 liters of urine is formed in the filtration as the filtration flows throughout the kidney, but only a very small amount of it actually leaves the body. This is because of reabsorption, which takes most of the water back into the body.
Reabsorption is the movement of substance out of the renal tubules back into the blood capillaries located around the tubules, called the pit tubule. Substances reabsorbed are water, glucose, and other nutrients, and sodium and other ions. Large amounts of water, more than 178 liters per day, is reabsorbed back into the bloodstream from the proximal tubulars because the physical forces acting on the water in these tubulars actually push most of the water back into the blood capillaries. This process is called passive reabsorption. The nutrient, glucose, blood sugar, is entirely reabsorbed back into the blood from the proximal tubulars. In fact, it is actively transported out of the tubulars and into the tubular capillary blood. And sodium ions and other ions are only partially reabsorbed from the renal tubulars back into the blood. For the most part, however, sodium ions are actively transported back into the blood from the tubular fluid, and the amount of sodium reabsorbed varies time to time. It depends largely on how much salt we take in from the.
Secretion is the process by which substances move into the distal and collecting tubules from blood in the capillaries around these tubules. Secretion plays an extremely important role in maintaining the body's acid-base balance. Substances secreted include hydrogen ions, potassium ions, ammonia, and certain drugs. In order to maintain pH balance, bicarbonate ions are also secreted to maintain balance. Substances are secreted through either active transport or diffusion across a membrane. So let's look at it from a different perspective. While reabsorption moves particles out of the tubules and into the blood, secretion moves particles out of the blood and into the tubules, where they mix with water and other waste products to be transformed into urine.
More specifically, filtrate starts from the afferent arteriole, where it comes in through the blood, and then goes to the glomerulus, where it then gets stored into the Bowman's capsule. Then, for reabsorption, it goes through the distal convoluted tube, or the proximal convoluted tube, down through the loop of Henle and around to the capillaries, where it is reabsorbed. Then finally, secretion occurs in the collecting duct, where the cortex, medulla, and pelvis is used.
Glucose reabsorption occurs in the proximal convoluted tube, and water reabsorption occurs also in the proximal convoluted tube, along with the loop of Henle and the collecting duct. And ions are secreted in the proximal convoluted tube and the loop of Henle, and the secretion of substances mainly occurs in the collecting duct.
We begin with normal water content, or homeostasis. Then it goes to overhydration, which is more water in the blood. Then the brain produces less ADH, and then there's low volume of water reabsorbed by the kidney, but the urine output is high. When going back to this and then going to dehydration, the water content of the blood is low, and the brain produces more ADH, and the volume of water absorbed by the kidney is high, and the urine output is low. ADH triggers an increase in water permeability in the membranes of duct cells. When ADH is secreted by the hypothalamus, it reaches the kidney in the blood and attaches to the receptor proteins on the duct cell membranes. This triggers the activation of an enzyme in the cytoplasm.
Specifically, in the case of alcohol consumption, alcohol can produce urine flow within 20 minutes of consumption, and increased urine flow results from alcohol's acute inhibition of the release of ADH. In the absence of ADH, segments of the kidney tubule system become impermeable to water, preventing reabsorption. Water is expelled through urination and is very dilute because of this. This also causes electrolyte concentration in the blood to rise.
Aldosterone is made in the adrenal glands, and then its job is nephron is recognized for its action on sodium reabsorption in the distal nephron of the kidney, which is mediated by the epithelial sodium channel. It also removes the amount of potassium in the urine. Aldosterone also causes water to be reabsorbed along with sodium.